All right, let's check out a little bit more about exponents, and we'll focus on exponents and multiplying. So when we have exponents and multiplication, there's three rules that we're going to practice and know. So it's the product of powers property, the power of a power property, and the power of a product property. So let's look and see what those things mean. So the first one, product of powers, it says to multiply powers with the same base, right? So like these bases are the same. You just add the exponents together. So if it's bases are the same and you're multiplying, right, then you would say add the 2 and the 3 together. So 4 squared times 4 cubed would be 4 to the 2 plus 3. That would be 4 to the 5th. Okay, that's the product of powers. The power of a power is when you're taking something raised to an exponent, like 4 to the 6th, and then you're raising that entire thing to another exponent, like you're multiplying it to the third power, right? You multiply those together. So if like you have 4 to the 6th already, now you're raising it to the third, these get multiplied together. So 4 to the 6th that is then taken to the third is the same as 4 to the 6 times 3, which would be 4 to the 18th. And then power of a product is where you have a product is like when you're multiplying, right? Like you're multiplying two things is the answer to a multiplying problem. So if you have 3 times 2 and that whole thing is being taken to the 5th, it's kind of like you're putting to the 5th of each thing. You're like distributing it to each thing there. This would be like 3 to the 5th times 2 to the 5th, right? So that's kind of how that works. So when you see same bases, you just add the exponents together when you're multiplying. When you have something that's to an exponent and then being raised to another exponent, you have to just multiply these two things together. And I remember that by just saying like, okay, well, there's a parentheses between these two things. And typically when we have like a number with like parentheses, that means to like multiply those. So that's what I'm doing here. And then this is kind of just like you're distributing an exponent. That's how I think of it. So it's like a number outside parentheses. You just distribute it into it. Okay, let's go down here. I put the little reminders up here in the corners to help us. Okay, so here's the product of powers, right? So same bases. We have to just add these exponents together. And it says write the product using exponents. So we want to say this is like 2 to the 9th. We're not going to break it down and figure out the exact number there. We want to practice writing it with an exponent. So 2 to the 9th is perfect. That's what we'll say. Right? Here, if it's -5, that's like -5 to the 1st. So if we're multiplying, right, that's what this says here. When a number is written without an exponent, it's an exponent of 1. So here, I'd say -5th remains my base, but 1 plus 6 would be to the 7th. Down here, 3 plus 7 would be x to the 10th. Here I'm going to say I've got 2x squared times 2x to the 5th. This is a little tricky. This is kind of like, these are each ones. So this would be like 2 squared x to the 7th. Okay. Down below here, we have x cubed times 2x cubed times y squared. Okay, so these are same bases, right? So I know that's going to be an x to the 6th. The 2, I'm just going to put out front there. And the y squared has nothing else to go with, so it's going to go kind of like that. So this is going to be 2x to the 6th y squared. Okay, go down here. Power of a power. So write the product using exponents again. This is where like a is being raised to the m, but then the whole thing is times to the nth power, and we kind of multiply them together to be m and n, right? We put them together. So this would be 3 to the 12th, because 4 times 3 is 12. Down here would be w to the 20th. Okay, power of a product. This is where we have to kind of distribute, right? Because we're multiplying things inside. each one gets to the third power. So this is like 2 cubed x cubed. This would be everything gets a square. So 3 squared x squared y squared. Right? Okay. Let's go down here. So a little more practice. So the first ones are product of powers, where the bases are the same and we add the exponents. So it should look like this. We got 6 to the 6th, negative 1/2 to the 9th. This would be z to the first, right? So that's z to the 13th. Down here, power of a powers, where we have to multiply these things. So this would be 4 to the 12th, y to the 8th. Ooh, and then here we have negative 4 to the 3rd. That's being raised to the 2nd. So this would be negative 4 to the 6th. Okay, power of a product is where we distribute. So this is 5 to the 4th, y to the 4th, a to the 5th, b to the 5th, and 0.5 squared, m squared, n squared. Gets to everything in there. Last thing, this word problem. This one's pretty tricky, so let me walk you through it. It says a gigabyte of computer storage space is the same as 2 to the 30th bytes. A gigabyte is like a lot of bytes, right? It's like a big unit for bytes. The details of a computer are shown. So then it says how many bytes of total storage space does the computer have? So the key is they want to know in bytes, right? So they want your answer to be in terms of like this, right? Like that's a byte, 2 to the 30th. That's like a gigabyte, right? How many bytes there are in a gigabyte. They tell us for the total storage space, it's 64 gigabytes. So I'm gonna rewrite 64. Pretty sure that would be 2 to the 6th. Yep. 2 to the 6th is the same as 64. Okay? So this would be like 2 to the 6th gigabytes. That's what that is. And we're going to multiply it by just one. This is like 1 gigabyte. Right? Okay, so let's take and multiply these things. Because if we know that like this is how we represent a gigabyte, and there's this many gigabytes, we can multiply it together to figure out the total number of bytes on the whole computer. So 2 to the 6th times 2 to the 30th, bases are the same. That's a 2. 6 plus 30. 6 plus 30 is 36. Looks like letter B right there. Okay, see you guys.